Hi, I'm Paul. We're doing a LeetCode problem today. It's called reverse nodes in K group. This is a hard problem according to LeetCode, and I don't know. Conceptually, it's not that hard. I think the hard part is in maintaining the pointers accurately while you're doing this. Okay, so reversing nodes. This is a linked list problem. All right, so reversing a linked list is um, it's easy. It's just a well-known solved problem. Okay, we know how to reverse linked lists. So keep that in mind as we look at what the challenge is. The challenge is given the head of a linked list. Whoops, I went too far. Given the head of a linked list, reverse the nodes of the list k at a time and return the modified list. K is a positive integer less than or equal to the length of the linked list. If the number of nodes is not a multiple of k, then left out nodes in the end should remain as they are. You may not alter the value. Yeah, that would be an easy way to do it. You may not alter the values in the list nodes. Only the nodes themselves may be changed. Yeah, so that would be a good way to do it. Is just replace the one node with a two, replace the two node with a one. Just replace all the values. Problem solved. All right, that's against the rules. What else? What else here? All right, that's okay. Follow up. Can you solve the problem in O1 extra memory space? Yeah, I think so. I mean, this is the kind of thing that you could do recursively. You could do the list reversal recursively, or you could do the top level problem, the K nodes recursively. Now, if you did that, you're going to use up extra space for recursion stacks. But if you just do it, with pointers, with manipulating pointers, then that should be O1 memory space. Okay, let's see. I will take a quick look at this so you can see what is being done here is for the first problem, here's the input 1, 2, 3, 4, 5. K is 2, so we flip the first two nodes, we flip the second two nodes. We don't have two nodes left after that, so the 5 is left as is, and so the result is this. All right, how can we do this? Well, let's say that we divide the list into segments of K nodes each, and we treat each segment as a list, and we reverse the individual segments. I mean, essentially, we're going to detach a K node segment from the list, reverse it, and then reattach it to the list. So that means we have to keep track of the pointer where we're going to reattach it and then handle the end case. All right, first thing I'd like to point out here is that we are going to use a subroutine here called reverse list. Now, LeetCode actually has a problem called reverse linked list. They rate that as easy. And here's one possible solution for it. And I just copied that into this. You can probably see that it's exactly the same. So we know how to reverse a list. We have a function to, or a method to reverse a list. So we can use that. All right, now the rest of it here. Let's see, where can we start this? All right. What we're going to do is, first thing, something I called a dummy node. This is an extra node that we're adding at the front of the list. It points to the head of the list. Now the head of the list is going to change because we're going to be reversing segments. So we don't want to lose track of the head of the list. So we have this dummy node that always points to the head of the list. We have another node. This is going to be called a node before reverse. This will be the node before the segment that we're going to reverse. Initially, that will be the same as the dummy node because the first node that we're going to that is going to be part of the reversal is the first node. All right, we have another pointer, current. Also starts out as the dummy node. You might think, well, why doesn't it start out as the one node? The count doesn't work out that way. So we set that also to the dummy node. Let me move this up as far as I can so we can see it. And maybe I can write on this at the same time. I'm going to pause this for a second and see if I can write something on it. All right, so I kind of sketched in our list as it exists. Now we have 1, 2, 3, 4, 5. We have the dummy node at the front pointing to the head. Well, we have some checks in here to make sure that we don't run past the end of the list. Current next, to make sure that we haven't reached a null pointer when we don't want to. All right, so the for loop here is going to move the pointer. Current is currently at the dummy node, the D. We're going to move it forward k nodes. K in this case is 2. If we move it forward k nodes, it's going to be pointing to the 2 here. We check to see if it's null. It isn't. All right. Now, next temp. We have to save current.next, which is the pointer to 3. The pointer to 3, 2 to 3. We have to save that. Right, so that's our temp node. We have a pointer to 3. And then we are going to say current next. Current is 2. Current next is, where is my eraser? Null. Okay, gone. We just detached the 2 from the list. So what we have is 2 lists. We have D, 1, 2, and then we have 3, 4, 5. Start is going to be node before reverse. That's currently the dummy node. Next, so start is here, 1, and we pass it to reverse list dot start. Okay, when that comes back, that's going to return a pointer to the reversed list, which consists of the 1 and 2 nodes. So what we're going to get back is a list like this, and what we're actually going to get back from it is this pointer right here to the start of the node. Then we can say start, which still points to 1. Start.next equals next.temp. All right. What that means is the 1 is now going to point to 3. All right. So what does the list look like at this point? What it's going to look like is, the dummy node will still point to the head of the list, which is now 2. It's going to be 2, 1, 3, 4, 5. Let me redraw it so it's not quite as sloppy. All right, D, 2, 1, 3, 4, 5. We need to reset the pointers for the next round. So node before reverse is going to point to start. Start is still 1. So node before reverse is going to point here. That makes sense because the next node that is going to be part of a reversal is 3. And current also current equals node before reverse. So current also equals 1. All right. Now we're done with the while loop. We're going to go back up. Current next equal null. It doesn't. Current null is not going to come into play here either, but we're going to move the current pointer forward 2 nodes. So it is going to point here, 4, right? And we are going to save current.next as next temp. Current.next, well, next temp is going to be 5. So when we detach the list and then reattach it, we want to reattach this this pointer here. All right, current next equals null. Current is 4. Current next is going to equal null. That means this is gone. It's not attached to the 5 anymore. So we detach the list. Start, node before reverse, next. So start is 3. Okay, and we pass 3 to reverse list start. It's going to reverse the list starting at 3. And so what it's going to return is 4, 3. This should look familiar. Returns that. Start, which still points to 3, will now point to, or start.next. Start points to 3, and start.next will point to next temp, which we saved as 5. So 3 is going to point to 5. So what we're going to have here, and I might be able to do this just by erasing it, is what comes back here is, let's see, node before reverse, next is the reversal list. Node before reverse is the 1. The reverse list goes in here for 3. And the pointer of start.next, which is the 3 node, 3.next, is next temp, which we saved as 5. So that's what we have. All right, reset the pointers. Let me erase those pointers. Where do we set them? Node before reverse equals start. Start is still equal to 3. So that is node before reverse. That's also current. Back up to the top of the list. Does current.next equal null? It doesn't. All right, so we'll go into the for loop and we will move the current pointer forward 2 nodes. If we do that, we're out here and we're actually, well, 5 will point to 5 will be a null pointer. So that will equal null. Current will equal null. So when we get here, current equals null, return dummy node.next. Okay. This is a test to see if we have k nodes remaining, which we don't. So we're done. We return the dummy node, which is still here, still points to the front of the list, and we return the list, which is now 2, 1, 4, 3, 5. Should be the correct answer. So, take the drawing off, move this over a little bit, and yeah, let's go ahead and submit. Move this over so we can see it. Okay, good runtime. There was that thing about the memory usage. Our memory usage is actually quite good. If we analyze the complexity, it should be O of 1. O of 1, yeah, because all we're using is pointers. There's no extra variables there. So that is. Sorry, I forgot the name. Reverse nodes in K group. Thanks for watching. Feel free to subscribe, and I'll see you next time.